Hey y'all, it's Mrs. Blasky. Today we're going to talk about topic 4.2, separation of solutions. There are 4 different ways that we're going to talk about how different solutions can be separated. It sort of depends on what your solution is and what it's made of as to which of these 4 methods are going to be the best. So the first method of separation is filtration. This is pretty straightforward. It's a funnel with a filter paper in it, and it is used to separate some sort of solid that is not soluble or insoluble from usually from a liquid. So a really common example would be sand and water, or if we made a precipitation reaction and we wanted to collect that precipitate, that solid, out from the rest of the solution, we'd put a filter paper in a funnel, we'd pour that solution through the funnel and the filter paper. The liquid would be allowed to drip through. That is called the filtrate. And then the solid would be collected in the funnel. We don't use that one very often except for precipitation reactions. That's usually the only time. There's a couple different types of chromatography that we're going to talk about. Chromatography, just from the word chroma, has to do with color. So we're going to talk about paper chromatography and thin layer chromatography, which basically work out the exact same way. And then column chromatography, which is different. So chromatography depends on the intermolecular forces of the constituents in your solution. We use what's called a mobile phase, usually a liquid, along with a stationary phase, whichever, usually those 2 phases have different polarities from each other. So if one is polar and one is nonpolar, that means a nonpolar component of your solution would be attracted to whichever phase is nonpolar. Your polar constituents of your solution would be attracted to whichever phase is polar. So here's a picture of paper chromatography or thin layer chromatography. They both work out pretty much the same way. Paper chromatography is exactly what it says. You would have a piece of paper here. And thin layer chromatography, most of the time, this, instead of having a piece of paper, you have a piece of glass or plastic with some other coating painted over the top of it that has been allowed to dry. We can do that if we need to control very carefully which polarity we need. When you have that would be our stationary phase, either the paper or the thin layer on top of the plastic or glass. Our mobile phase would be a solvent down here in the bottom of the beaker. Lots of times it's water, but it doesn't have to be. And then you would place a spot of whatever solution you are trying to separate, but it has to be above that liquid line. Otherwise, it's going to dissolve down into that solvent and never travel. So we put that ink spot above the liquid line. We allow that solvent, that mobile phase, to absorb up the paper. And whatever substances are in that solution that we put a spot down there are going to separate out. As these travel upwards, if our solvent in this case is water, water is polar. So as that solvent travels up, the polar constituents of that mixture are going to travel up with the water. The non-polar constituents are going to be more attracted to the paper or the thin layer of material on top of the glass or plastic, and so they're going to stay lower. So if we have multiple spots show up out of our mixture, we can say, well, down here at the bottom, this one would be the most non-polar because it stuck to the paper the most. This up at the top would be the most polar because it traveled the farthest with our mobile phase, which in this case is water. Now, if our mobile phase was something that was non-polar, if it was propane or butane or hexane or something like that, then as that non-polar mobile phase traveled, it would pull the non-polar parts of the solvent, of the solution, farther up. If anybody's ever done as a kid or with your little brothers or sisters or anything, where you take markers and you put it on coffee filters, and then you let water onto it or alcohol onto it and drip it out and it makes rainbows, that's paper chromatography. Being able to see the colors that that ink separates out into is chromatography. Another type of chromatography is called liquid chromatography, or sometimes it's called column chromatography. Same idea, only we're set up differently. Instead of waiting for that mobile phase to absorb up a piece of paper. We're going to let gravity do its work, and that mobile phase is going to be poured down into some sort of tube. Oftentimes it's a burette with it's got to have an opening at the bottom though. So our stationary phase is packed into that burette. We put drops of our mixture that we want to separate on top, and then we pour the mobile phase through that burette, let that drip through the bottom as that mobile phase travels through. Again, whichever is most similar in polarity to the mobile phase is going to come out first. Whichever one is most similar in polarity to your stationary phase is going to stay in that tube or that column longer, and it's going to be the last to come out. This method is best for things that we actually want to collect, because we can actually collect those samples out of the bottom, and then if we needed to use them for something else or we needed to analyze them some other way, we could do that. Last type of separation that we're going to talk about is it's called distillation. Distillation takes advantage of the differences in intermolecular forces based on how they affect boiling points. So if we have a mixture of, usually we do this with liquids, a mixture of liquids in here. In that mixture, you would have different liquids that have different boiling points because they have different types of intermolecular forces or even different strengths of the same intermolecular force. You would heat that mixture. Whichever component of that mixture has the lowest boiling point would start to boil off first, turning into a gas. And then up here we have what's called a distillation tube or a condensing tube, where we run cold water through this. So as that gas rises up, it would get forced into this tube and it would condense back down into a liquid. So the only thing getting condensed down through that condensing tube on the right is whatever chemical is being boiled off first. Then once we notice that we've reached a heat past that first boiling point, maybe there's a second or a third chemical in that mixture we want to separate out, we would remove this, place another beaker in there, and then we'd keep heating till we reach the boiling point of the second chemical that we want to separate. This is best for large samples of liquid that we need to separate and when we want to be able to collect that sample again. When you do thin layer chromatography or paper chromatography, you can identify what's in that mixture, but it's not like we can collect it because it's just a little dot and it's absorbed onto that paper. So this is a lot of vocabulary. There's always questions on the AP test about these topics, but it's usually not a ton. You do need to be able to recognize what setups are for which type of separation and what situations work best for each type of separation.